Hi everyone, it's 10 a.m. so let's get started. So, so welcome to the third mission control workshop. This is on deployment, and this is the first part in first of two parts. The first one is on deployment to web, and the second one is mobile deployment. And because the second part also covers topics such as data storage, we expect that teams that sign up for deployment part one will also sign up for part two in order to get a more complete picture of how to essentially manage deployments not only of front end and back end services, but also um, no, also data storage essentially. So before I proceed, can I just confirm that you guys can hear me clearly? I've already started the recording, so I just want to make sure that there's no issue. Yeah, okay, cool, thank you. So, so without further ado, I'll just start this off. People are joining in as well. So I'll just give a quick outline to what I'll be covering today. So this is somewhat like DevOps, but not essentially. DevOps is typically done in more larger companies where you're looking at processes to ensure that there is this security and this continuous integration and deployment. But at an orbital level, uh, the purpose of CI/CD is just to ensure that you have a pipeline that is. Just give me a second, sorry. Yeah, so essentially it's to create a pipeline such that you have any code changes that are made to your GitHub is immediately pushed and deployed to production. So production environment is different from a local environment. I'll explain the differences as and when we go. So then once we look into what CI/CD is, we'll look into cloud service providers. So today's focus will be primarily on GCP, Google Cloud Platforms. The first thing is it has like $300 worth of free credits. So definitely you guys will be able to use it for Orbital and not have to pay out of your own pocket. AWS, on the other hand, does have a free tier, but the problem with AWS is that it is pretty easy to exceed those costs. I personally have done it many times, and yeah, I've lost quite a bit of money. Let's just say that. So after that, we'll be looking into what containerization is and why it's very useful in our particular case, and how it's basically extendable for any backend service that you're using, and what Docker is. So Docker is the most popular containerization framework, and it is the industry standard. So if you guys are applying for internships the next year and you do have Docker in your resume, definitely going to look good. So when it comes to Docker, we'll be looking at what different components of Docker are, the Docker network, Docker engine, and also we'll be looking into how we can create Docker images and Docker containers using two things called a Docker file and the other one's called a Docker compose. So once that's done, we'll be looking at the advantages of using Docker for local development, and I'll also be doing a quick demonstration of setting up backend web services on Docker. So for this, I have a repo that's already in hand. So I don't expect that you guys will be able to follow and code along because it does take some time. So I'll just be doing a speed run through, and I've already set up most of the stuff beforehand. So what ideally would be the case is that if you want to refer to some part of the video um, at a later date, because the recordings will be uploaded, it you guys can do so. So it'll cover all the concepts that you need in order to be able to do deployment, but it's not going to be I do and then I wait for you guys to like essentially catch up and follow along. So it's going to be pretty fast. I would highly recommend you guys don't try to follow along. Just look at the concepts that are there and then get a rough idea of how I'm doing the deployments, and uh, yeah, just follow along essentially. So I'll also be exploring other options such as AWS EC2, very briefly though, but the main thing that I'll be focusing on today is GCP Cloud Build and Cloud Run. And these two services essentially work together. I'll also be looking into Cloud SQL. So if you want to connect from GCP Cloud Run, which is basically deploying your backend service to a database, then essentially there are options for that in GCP such that you can connect from, let's say, a Django REST API or a Fast API service to your Cloud Run. So then after that, we will be looking into deploying front-end applications with Vercel. The reason I've pushed this to the very end is because one, it depends on the front end depends on you deploying the backend, and the second is that it is relatively a lot easier in order to deploy the front end compared to the backend. It's just basically plug and play. But yeah, don't worry, I'll go through that as well. So, okay, so just a quick intro about me. I'm a year 4 graduate. I go by Vaishnav, if that's more convenient, by the way. So I'm a year 4 computer science graduate at NUS. Alumnus of NOC Toronto, author at ACM Ww25. So there I essentially published a paper on LLM architectures for text to visualization. So there was where I predominantly used GCP for deployments. And even though it's an open source application, we did demo it and deployed the backend service on GCP as well. So yeah, so I'll be using that particular application today in order to demonstrate how to essentially link GitHub to a production environment. Yeah, so I'm also running consultation sessions for generative AI on the 7th of June, 2025. So about a week from now. So if you guys are working on any generative AI applications, do feel free to sign up. I'm also doing another workshop later today on generative AI from 1 to 3 p.m. So yeah. So let's start off with what CI/CD is. CI/CD basically means continuous integration, continuous deployment. Basically, any changes that you're making. So when you're working on features, and obviously in Orbital, they talk a lot about iterative development. Any features that you're pushing, any code changes that you're making, any bug fixes, should be continuously pushed and integrated into the production environment without any need for manual intervention. It should not be that somebody needs to manually go and click some button or run some script in order to be able to push those changes to production. So every time I make a pull request, so for those who have not attended the Git workshop, a pull request is basically trying to push what you have done, your code changes onto the main branch, and essentially which is the main I guess source of truth for a particular project. So any changes that are made, let's say if you push merge to main or if you merge to a specific branch, it should automatically trigger a deployment of the latest version of either a REST API or the latest version of the front-end code into production. So the way we'll be doing that for front-end is Vercel. So Vercel sets up a deployment pipeline by itself, so you don't need to really plug and play. When it comes to backend, we'll be using something called GCP Cloud Build. And what Cloud Build does is it sets up a pipeline which is based on Docker, and I'll explain what Docker is in a while. And it basically pushes it to something called a service called GCP Cloud Run. And once it's on GCP Cloud Run, it's basically visible to the entire internet. And if you want to query a REST API, you can do so by just calling the endpoint. So you have the URL, and then whatever comes after it is basically the API endpoints that you have. So the API paths essentially. So every pull request to the main branch of GitHub or any version control manager system. So like, let's say you have Bitbucket or GitLab, it should trigger a pipeline that builds and deploys the latest version of the application onto the production environment. Given that most people are using GitHub, I just decided to use GitHub for this demo as well. So this existing application has already been deployed to GCP, but I'll be going and showing you essentially how I did those deployments and what variables are there to monitor. And just to give a brief idea of what a CI/CD pipeline looks like. So if you can see here, so this is the latest commit for this particular GitHub repository. So this is the example that I'll be working with today, and this is the one that I've deployed to GCP already. So this is the final product, right? So if you see here, there are 3 successful checks. So Vercel also runs a few tests on its own to see that it's able to build your front-end application. So it runs a command called npm run build as part of its pipeline to make sure that you don't have any breaking changes. For example, you're not importing anything that you're not supposed to. You don't have, you're not using a package that you've not done an npm install on, for example. So you can see here there are different checks that are being done. Vercel's doing these two, and what you see here is basically your GCP cloud build. So if you see details here, you can go and then see. It basically leads you to the Vercel page. Similar for, whoops. Okay, so yeah, and if you go here, you can look at details. It will, yeah, you can see the build information as well. And if you want the build log, you can go to the Google Cloud Console, and I will explain more about how you can set this up, but just basically a brief idea as to what deployment looks like. So every time I push a new commit, these three checks will be running. So if you look at the past 927 commits, you can see that it either passes or fails. So if you see here, some checks were failing here. This is because this is the previous GCP cloud build, and which I eventually brought down. So yeah. So before we proceed with setting up cloud build, cloud run, and going into Docker, let's start off by asking what's the difference between a local and a production environment. So a typical production environment for web applications would be you have a web app that's running on your browser. That's basically your client. Your client communicates over the internet with a REST API service. The reason you have a REST API service is, one, it's a good interface with your database. The second is it needs to run, your web service will basically be running some sort of business logic or application logic that is needed to process each request, and it's not feasible to run those requests on from your front end. So that's the reason you have the REST API as a middleman, which serves data from the database according to predefined rules. So and then you have a database server which hosts your database, and it's running, it basically has, it's storing the data that you have. So this is your production environment. But when it comes to local deployment, so local development essentially, the problem is that you don't have three different computers to basically run your code. So you have your front end, which is your application that's running on your browser. You have your back end, which is again your REST API and database. All of them are actually running locally when you're doing local development. And the problem that can happen is that, let's say if I'm working on Orbital with a teammate, there can be some dependency mismatch, and there can be some difference in the development environment, which is causing the application to break. So I think I have this meme right here. So as you can see, somebody's saying that it works on my machine. So, but the problem is that it's not your machine that goes into the production environment. So you don't know for a fact whether your REST API will work in production or not. And to combat this, there is something called Docker, which I'll introduce in the next few slides. You could technically run your backend service on an EC2 instance. An EC2 instance is an AWS service, which basically gives you an entire compute instance that allows you to basically run containers and respond to HTTP requests essentially. But accessing these cloud compute instances are not only costly, but also very time consuming, and they have a huge latency if you're trying to access, if you're trying to develop on it. So definitely local development is the way to go. So you have different services that are running on localhost but are using different ports. So let's assume that I'm using React.js as a front end, Postgres for my database server, and Fast API as my API server. So the default ports, for example, for React.js is 5173, used to be 3000 if I'm not mistaken. Postgres default 5432, Fast API is 8000. You can configure these, but essentially think of each port as something that maps to a process. So Setting up a local development environment is time consuming, especially if the dependencies change over time, and it can cause the application to break if you don't have a consistent environment between two developers who have different local environments, and also between local and prod. So, in order to create some level of standardization, there was a new concept involved called containerization. So, an application needs to run reliably across different computing environments, different developers' laptops, and also the production server. So, in order to ensure consistency and also to be able to package an application with its dependencies and efficiently push it to the production environment. Um, so yeah, you have this sort of bundling where an application is in a standalone container packaged with its dependencies, and it's being abstracted away from the host operating system, so that the host OS is not the one that's impacting whether the application is able to run or not. So essentially, you don't have the excuse that it works on my machine, but it doesn't work on production. So yeah, I think it's quite a funny meme, but it kind of effectively summarizes how Docker was created and came into existence. So, what are the benefits of containerization? As mentioned before, portability. So, a container can run that's standalone. It's been abstracted away from the host operating system. So, once I push something to GitHub, let's say if I have a container and I push it to GitHub, all I need to do is somebody else can git clone, and if they have Docker, they just need to do Docker compose all build d, and then they basically have the Docker containers that are running. Also, it's more efficient than virtual machines. So prior to Docker, virtual machines were the way to go because it didn't effectively abstract away the host operating system, but it created a similar environment for the testing of multiple applications. But however, virtual machines are pretty expensive to run, and they use quite a bit of RAM as well. So yeah, containers are pretty much more effective in that particular sense. You can also create and deploy your applications much faster, and there is a lot more scalability because you can add multiple containers to a single machine or across a cluster to handle increased load. So let's start with an introduction to Docker. Docker is, as I mentioned, the most popular containerization platform. It's open source, and it has a toolkit that enables developers to build, deploy, and manage containerized applications. So I know I did mention that it's a prerequisite to have Docker and Docker Desktop installed. I did share a couple of links, but it's perfectly fine if you don't have them. Just watch through and then go through it at your own pace. If you have any questions, you can always email me. Um, yeah. So basically, to deploy Orbital projects, the reason I chose Docker for this workshop as well is because um, it is agnostic, right? In the sense of what language and what framework you're using. So if I'm using Node.js, or if I'm using, let's say, Django, Flask, Fast API, uh, the containerization is handled by something called a Docker file. So once you have that container, everything else is abstracted away. The rest of the process is the same. How you use GCP Cloud Build to essentially um, get it to get triggered by any push to the main branch, and then eventually built and then deploy to Cloud Run. So that's basically how Docker helps, I guess, and it's also an industry standard for containerization. So it's kind of a requirement nowadays for internships in software engineering. So it's definitely a value add for your resume if that's something you're looking for as well. So let's start with some pretty fundamental Docker concepts. And the reason I chose to go a bit more theory heavy compared to just starting off with a demo is because it's very important to get these fundamental concepts right before we look into what a Docker file is or what Docker Compose does, so that you actually are not lost and you have some sort of a context as to what's going on. So Docker images. So you have two main things. One is a Docker image and one is a Docker container. So Docker image, I assume most of you are done CS2030S, so you guys would know what a class and what an object is. So an image is basically a read-only template that contains instructions to create a Docker container. So Docker images are basically built in layers. So it has layers of instructions to create a Docker container. A Docker container is a live instance of a live running instance of an image. So it basically, sorry, just give me a second. Oops. Okay. Yeah. Sorry about that. So yeah. So it's basically a read-only template that contains instructions to create a Docker container. A Docker container is, as I mentioned, a live running instance of an image. So it basically packages the application code, runtime libraries, and all the dependencies that you need, and also the environment variables with configuration files. So here is a very important point. When it comes to your local development environments, you should never ever put any sort of secrets, for example, like your database authentication, your password, and all, directly into your Docker file. It should always be in a .env. And the .env should be added to your git ignore because you basically don't want to push your secrets to GitHub. Ideally, it should be transferred through a more secure medium with your teammates. And eventually, when you're pushing it to the production environment, um, you should, as I will explain, there's a method to actually manage secrets on GCP, and will be fed in directly from the secrets manager into your running instance. So you should never like hard code anything that is sensitive and that has sensitive information. For example, like your API keys for like OpenAI. If that's something that you're using, definitely don't mention put it into either your Docker file or your Docker Compose.yaml, because these will get pushed verbatim to GitHub and won't be added to your git ignore. For those of you who didn't attend the Git workshop, git ignore is basically a file that contains a list of other files that should not be tracked by Git and will not get pushed to GitHub, even if any changes are made. So yeah, you typically don't put your .env file, your environment file, to git ignore because you don't want to accidentally push information that is sensitive in nature. So yeah, this is pretty important. Just make sure that you take note of this. So there are existing images on the Docker Hub because nobody can be expected to build their own image at any point in time. At many times, I would want to use a pre-existing image, an image can be a runtime, for example, like Python, or it can be an operating system like Ubuntu. So let's say if I want to build an image on top of it, it's basically a text file with instructions where it's built layer by layer. And you will understand more about what I mean when I say layer by layer, but you basically have a base image, and based on top of that, you give additional instructions as to how to build your own image, let's say with your own REST API service on top of the existing image as well. So yeah, so if you want to rebuild the image, you basically change the application specific layers on top in something called a Docker file, which I will get to very quickly in a bit. So Docker Hub is also is a very important concept. It's a centralized registry that's containing pre-built images that can be pulled. So let's say if you're saying from Python 3.9, so that is the base image, and this basically means that every time you try to build your current Docker image, the Docker engine will see that you're in your Docker file, you are calling an existing base image, and that image will be pulled in order to essentially work with, and that'll be your base image as well. So that was basically Docker images. And you have Docker containers, which is basically a runnable live instance of a Docker image. So a rough analogy, as I mentioned, a Docker image is like a class, and Docker container is a running instance of the Docker image. Containers are isolated from each other and from the host system. So they are like standalone applications. Multiple containers can be created from the same image. So for example, multiple objects can also be created from the same class, right? So class is basically a series of instructions on how to create an instance or an object, and different objects can also run simultaneously. So that's the analogy you guys should be thinking about when you're looking at Docker images and Docker containers. So what's the relevance of this if you have like some sort of a REST API application? Essentially, your REST API, you would have dependencies and instructions to basically build your REST API. Today, I'll be giving the example of Django for an existing application that's already been built. But essentially you'd need instructions to basically package it along with its dependencies. And in that particular sense, you would need a Docker file, which basically specifies the image that, or rather the instructions to actually build a Docker container. And once you run the Docker build command, the Docker file is basically built into an image. So yeah, you can create multiple containers from the same image, as I mentioned. So yeah. A very important concept is the Docker engine, which consists of the Docker daemon, Docker client, and a REST API. So these are three main components. I'll explain what they are. So Docker daemon, a daemon is basically a background service that's running, and it manages Docker objects such as images. Images, obviously not pictures, and I'm referring to Docker images here. So instructions to basically create containers, networks, etc., and also something else called volumes. So I'll explain what volumes are in a bit as well. So it listens to API requests from the Docker client. The Docker client is basically a command line interface that interacts with Docker. So you can run common commands like docker run, docker pull. Later I'll be showing you how to essentially build and run containers within a single command. It's called docker compose. So yeah, so the last thing is basically the REST API. Yeah, sorry, 1 second. Okay, so I've been getting questions as well. I'll take a break, maybe around like 5 minutes to answer queries. Just feel free to type them in the chat, and if possible, please put them as not a direct message so that everyone can see the questions that are being asked. So it's helpful to everyone as well. So yeah. Thanks, thank you. So, oops. Yeah, so you have something called the Docker REST API, which defines how applications or any like application that you're packaging can interact with the Docker daemon. So these are all like more technical implementation details. You don't really, this is more of like a good to know that there is something called a Docker engine. And if you're running something called Docker desktop, you can, I provided the link to that in the pages. You can basically follow it to install it. It really depends on which OS you're running, but the installation instructions vary. But yeah, so once you have that, you basically kind of have a good idea of what a Docker engine is, and but you don't need to know too much about the Docker daemon, the client, or the REST API. It's just a good to know. So the Docker Hub, however, is pretty important because it's basically a registry, and it's a centralized storage and distribution system for Docker images. You can also have a private registry. Many companies will have those, but again, for Orbital, if you're working with a pre-existing Docker image, most likely you're going to have to pull it from the Docker Hub. It's the default public registry. So if you're having any like for example, if you see this line of which will be usually put in your Docker file here, it's from Python 3.11 Slim. So this is an example of the base image that you're using. So once you put something like this, Docker knows that it has to pull from the default public registry. If you want, you can pull from other registries as well. There are methods to do that, but I would definitely recommend using the public registry because it is the most popular, has the biggest community, and if something breaks, obviously, it'll probably be the place where it's most likely to be fixed fast. So it hosts a vast collection of official and user-created images that can be pulled and used. So for example, here you're having a Python base image of Python 3.11. Slim basically means only using dependencies for Python 3.11, which are absolutely necessary in order to be able to run the Python image into a container. So this would basically pull the latest Python image from the Docker Hub. So very important concept that you cannot escape is something called Docker volumes, and this is the example syntax. This is not in your Docker file, but rather something else called Docker compose. I'll get to what the two of them are. So Docker volumes are basically, let's say if I have a database with users data, and every time I'm making any sort of changes, I don't want the data that is there in my database tables to be erased. I want it to persist because I'm testing out features. Let's say if I have some sort of a bug, I'm reloading my Docker containers for some reason. I don't want it to be such that my database gets erased. So Docker volumes is basically something that is basically a tool that allows data persistence, so that any data that is generated and used by these Docker containers is stored in some sort of a directory on disk, so that in that under the file directory, and typically data is lost when the container stops. But when you have Docker volumes, all the data that is generated by your Docker containers is stored in a particular directory. So there is a dedicated directory on the host machine. So as you can see, volumes. So this is under the backend service, and I'll show the entire Docker compose in a bit, but I'm just focused on this for now. So it allows you to basically store any data that is generated by the Docker application, Docker container, into this particular directory. So yeah, that's essentially what a volume is. It's pretty important, especially if you're working with data persistence. Docker volumes is a must. And I will actually show how this fits into the bigger picture. So just hold on for now. So before I proceed with Docker networks, I will just answer any questions. Okay, so does Docker container have anything to do with front-end Vercel deployment, and what are the limitations of Vercel? Okay, when should we consider deploying our applications on a cloud provider like GCP, AWS, or Microsoft Azure? So these are two separate questions. So Vercel is not exactly a cloud provider. It is basically a deployment service for front-end applications and exclusively for front-end. So for most of the popular front-end frameworks, React, Next, Angular, Vercel basically has its own custom deployment pipeline. Today I'll be demonstrating it with React. So if you want to deploy your front-end application onto Vercel, you can do so using the steps that I will mention later. You can also deploy front-end. So Docker is not only limited to backend services. You can also containerize your front-end application and deploy it to GCP and AWS, but it's just slightly more complicated. And also it's not free in the sense that you'll probably be either expending your free credits that you have, or you'll be spending a lot more money. So yeah, it doesn't really make much sense to deploy your front end on Docker. And also this is just mainly from personal experience. When I usually run front end on Docker, it tends to be a lot slower than just running it as a standalone application. So Docker typically works well for backend. For front end, I would still suggest when you're running it locally, just do an npm run dev, if that makes sense. Not sure if that answers your question. Sorry, yeah. So the second part is basically, when should you consider deploying your applications on a cloud provider like GCP, AWS, or Microsoft Azure? So that's a good question. So typically when I see Orbital projects, most teams, either they tend to use backend as a service. So for example, like either Supabase or Firebase. So when it comes to like Firebase or Supabase, you're not having any sort of like dedicated REST API service that you need to host on the web or on the cloud. Typically, for Orbital, you would need to go serverless if you were planning to host a REST API service. You can also consider other options like Supabase. There is another one called Fly.io that basically allows you to host your own REST API services. But GCP, AWS, and Azure, these are basically pretty well-known cloud providers, and they do have some sort of an integrated CI/CD pipeline that you can use. AWS or EC2, for example, you can basically just deploy an entire Docker network using a CI/CD pipeline, but it's slightly more complicated because you would have to use something called GitHub Actions for that. So yeah, would definitely say that if you're running a REST API service, GCP Cloud Build and Cloud Run is probably the easiest to work with. Heroku is probably another very popular choice amongst people who are doing Orbital. Yeah, hope that answers your question. So the second one is, generally, when should I use Docker containers in my dev environment, since services usually host themselves in separate pods? That's another really good question. So Docker containers have two advantages, as I mentioned before. The first is that it ensures the uniformity of um, the dependencies, and yep, there's another question as well, but I'll answer that in a bit. So you have, so when you want some sort of uniformity between developer environments, you would typically use Docker. So let's say if I have a requirements.txt, so I would definitely create a virtual environment in order to manage the dependencies for a particular backend service. But if I want to make sure that two different people don't have to like keep on reinstalling dependencies, and you want that to be automated, Docker is a really good choice because you just need to do Docker compose, and once that's done, all the process of building the installation and building containers and to be able to run those REST API services is a lot more automated. That's the first, but the main advantage is that it's easier for you to achieve uniformity between your local environment, your dev environment, and the production environment. So you it's easier for you to package your application with its dependencies, and you know that if it works locally, it will work on the cloud environment as well, provided that you've provided all the secrets that you need to through GCP, which I will explain in a bit. So when should you use serverless and when should you use something like EC2? So any cloud instance is actually serverless. So what serverless means is that you're not managing your own server. So typically you would use serverless for Orbital because in the only places where you would manage your own service is basically very security critical companies where they want to essentially manage their own makeshift servers. In most cases, you would ideally work with cloud. So cloud is basically serverless because AWS is managing the cloud instance for you. So I hope that answers your question. Cool. If anything, just feel free to text here. I will get to it. Yeah, cool. Sure. So we discussed Docker volumes, which basically showed us how we can persist data even when we're basically bringing down and rebuilding containers. So Docker networks allows containers to communicate with each other, the host machine and the external networks. So it allows for networking between containers and the outside internet, and this is managed by the Docker engine. So this can be created using the docker compose.yaml file. So the demo is coming up, as I mentioned. So as you can see, there are two main files. The Docker file is basically a set of instructions to build a Docker image. Docker compose basically lists down all the services that have to be built. You can use a Docker compose in conjunction with a Docker file because a Docker compose can also mention a particular service and point to a particular Docker file and say this is how you build a Docker image. And Docker compose.yaml can also pull like existing images, for example, Postgres, Postgres 15, let's say that's the latest version of Postgres. If you want to run it locally and on a particular port, it's a lot easier to get Postgres configured if you're using Docker, by the way. So yeah, so that in that particular cases, you would ideally want to use a Docker compose.yaml. And it essentially helps maintain a Docker network, and it also helps specify the order in which you want your Docker containers to be created. More on that later, but yeah, so that's basically a brief introduction to Docker networks and how the Docker compose fits into it. Oops. Yeah, so here we come to the demo. So as I mentioned, this is the rough structure of a Docker file. So I'll be demonstrating this with respect to another application, but I'm just going to explain what each line does. So you can see this is the official Python runtime image. So you say from Python 3.13. So what this essentially does is it pulls the latest version of Python, the image that is there on the Docker Hub. And if you remember, I mentioned that the Docker Hub is basically a registry, a centralized registry that contains all the images that need to be run. So this can either be Python, which is a runtime, or you can have Ubuntu, and based on that, you can build your image as well. So then you create something called an app directory. So when you're doing run make dir app and work dir app, you're you're not CD'd into, you're not inside the app directory yet. You're working outside of it. So you always need to make sure that every time you're copying something into the directory, you're specifying app so it knows the target directory as well. So that's there. So then afterwards, you have two environment variables. So you're setting Python dot write byte, don't write bytecode equals 1 and Python buffered equals 1. These two lines of code, without getting into too much detail, basically ensures that any log information or any print statements that you're making will be printed onto the Docker container into the command, basically the command line that I'll show later. So once that's done, you're running pip install upgrade pip. So for those of you who are not very familiar with Python, pip is basically a Python package installer and package manager. So you're basically upgrading pip, and then you're copying over something called the requirements.txt. Requirements.txt is where you've mentioned which libraries you need, and this is a very Python specific. So for Java, for JavaScript, you'd use something like package.json to basically to list down the list of dependencies that you need. And in this case of Python, you're basically running pip install and r requirements.txt. R basically means that it reads through the requirements.txt and installs every single requirement that you have. And once that's done, so the reason you're copying over the requirements.txt first is that you need to install the requirements before you can copy over the entire application. So that's why you're copying the requirements.txt first, and then you're copying over the application. So now that you see, you can copy over the Django project to the container, and then you're exposing the default Django port, which is 8000. And CMD is basically when you want to run a bash command. So Python managed to py run server is how you essentially would spin up a Docker container. So the advantages here is that every time you're building a new image, the Docker file basically contains all the instructions that you need in order to build the new image and to install all the new dependencies, etc., and to deploy the new production server. So when you're essentially deploying it to the cloud, deploying the Django application to the cloud, if you have any new dependencies, any new libraries that you're using, you can basically, it's basically automated through the CI/CD pipeline that I will show later. So if you want to build a Docker image, the command is docker build t Django Docker. So that's Django Docker is the name of the Docker image that you're giving it. So it can be anything. So Django Docker is a custom name that you're giving, and tag is latest. So the default tag that is given to every tag is some sort of like versioning. So it's the default I guess label you're giving to each image. You can give different tags and you can manage different containers of the same image as well that way. But every time you push, the default will be the default tag will be the latest. So every image has a unique image ID, and obviously you can see the size as well. So yeah. So very important is the docker compose.yaml file. So this is an example. I'll also show this to you on my VS Code in a bit. But as I mentioned, it helps you run multi-container applications within a single network. As I mentioned before, declare secrets in your environment file. I will show how that's done in a bit. Do not push your environment file to GitHub. Configure the services that you want to run. So as you can see, services basically specifies two services that I'm trying to run here. The first is backend. Ignore the different sizes. I just try to fit them into the slide, but basically it should be services, then backend, then DB. They should be indented. But yeah, I was just trying to fit them all into a slide. So, let's go through each service one by one. So in backend, the build file is basically the backend repository. So here I'm assuming that it's a mono repository. So how the file structure would look like, if I can show this to you very quickly. So I have front end here and I have the backend. So in the root repository, I have the docker compose.yaml file, which basically contains the instructions to build the Docker container, the Docker network essentially. So when I say build backend, I am pointing to this repository, and this repository contains the Docker file. So the Docker file, as you can see, it's very similar to the one I showed you just now. It's just that I added a couple of more lines to ensure that there is hot reload. Hot reload essentially means that every time you make a change that does not involve the addition of any new dependencies, the Docker container will essentially stop and restart. So these are the different libraries that you need in order to ensure hot reloading. There's something else called worksug that allows you to run server plus, but I think it's beyond the scope of this workshop, but you can basically check this out if you're using Django, essentially. So, and if you want a hot reload as well. So as I mentioned before, Python buffer 1 ensures that output is sent directly to the terminal. So if I have a terminal here, any sort of like error messages or something should be printed here instead of being written to disk, etc. And the environment file, so as we can see here, I have an environment file that's being taken. So I'm not going to expose my secrets, but yeah, it's basically contains these variables. It's a key value store. So if you have Postgres user password DB, yeah, you can be it basically pulls all the required secrets from the environment, and you can specify the ports. So for reasons I'll not get into, I basically mapped port 5433 to 5432. So essentially what it means is that you're mapping the host machine's port 5433 to the container port 5432. So that your host machine will have a port and your container will also have a different port, and these two ports will be communicating to each other. So the host machine is the one that sends sort of API calls to the container. So yeah, that's basically what the port mapping means. So when it comes to the DB, you can see that the image is Postgres 15. You're pulling it from the Docker registry, and you're setting the environment here. Alternatively, you can also set the environment using the .env file. So you can say environment file is .env. But here, if you see here, it mentions that it depends on DB. So this basically means which service does my backend depend on in order to be able to in order to be able to start. So since you specified DB first, the DB container will be built first before you build the backend, which kind of makes sense because your backend upon start will need to connect to the database, and if it's unable to do so, it will probably it will basically crash, right? So it's basically a case of dependency. So DB is basically a dependency for the backend. So you would want to make sure that your backend depends on the DB. So as I mentioned before, backend volumes. So I'm setting up a directory under the backend directory, backend/backend, such that every time any like data is generated, it is basically stored in that particular volume. And then when it comes to Postgres, so I'm setting up a volume called Postgres data, and this is basically the name of the volume, and this is the directory that is set. This is like default for Ubuntu. And once this is done, every time you have any new data that is added to your Postgres database, it gets stored into your Postgres volume, essentially. So that's essentially the crux of what the Docker Compose YAML file is. Let me just see if I missed anything out here as well. So I'm going to give the link to this repository so you guys can check it out and see essentially how the different parts of the Docker Compose YAML. Since we're kind of strapped for time, I'm just going through them very quickly. But yeah, that's basically the entirety of the Docker Compose. This is your Docker file, and it's just a few lines of code, right? So many times if you're like stuck somewhere, you can always refer to the Docker documentation. So I'll be proceeding ahead. Okay, so now that we've looked how to set up a Docker file and Docker Compose. So since I'm running a network here, I will need to run my DB first, and then I will need to run my backend second. So the command that you would use here is called Docker Compose up. So what it does is, I'll explain one by one. So Docker Compose is basically the command line such that that you need to run a Docker compose.yaml file because you're running a Docker network, which contains multiple containers. So the build flag ensures that the Docker container is first built. The Docker image is built first before you're spinning the container up. So once that's done, you're basically building and spinning up the containers in the same go. D is basically a flag for detached. It really doesn't do much except make sure that your terminal does not hang and you can basically proceed to do other processes. So basically, your Docker runs as a background process and you can use the terminal to run other commands as well. So that's why you have the D command. So once you have put this up, so I've already spun up my Docker containers, but just for the sake of demonstration, I will delete these containers and run them again. I'm just going to delete these. Okay, it's going to take a bit of time. Okay, while I am on that, okay, it's deleted. All right, sure. So once I've deleted that, I'm going to run again. So I already have like a front end that's running, and the reason I mentioned that I run npm run dev normally is because front end like usually takes really long to load on Docker, and you don't need Docker to be able to deploy front end applications. You can just use Vercel. It's a lot easier compared to like Docker containerizing it and then deploying it onto a cloud service. So let's run this command. So as you can see, it basically follows all the instructions in the Docker file. So your DB is already spun up. It's created because your backend depends on your DB. So a lot of it is cached. So I did not update the requirements.txt file. So there is not much of a change. So as you can see, it's run all the commands in the Docker file. So copying the requirements.txt, setting up the backend directory, which is the working directory where all the files of the project will be copied to. This is within the container. So yeah, you can see these are all adhered to. So, but however, there is an exception. So let's say if I go to my requirements.txt and add, for example, let's say if I add some other library. So do I have pandas? No, I don't. Okay, so let me just add pandas for the heck of it. So here, actually, just okay. So I'm just going to install pandas. Okay, let's just put 2.2.3 for the heck of it. And now, okay, so now that I have a new dependency, the cached version of Docker where all the dependencies that have been cached won't be used again. So what will happen is there will be another round of pip install.txt as we will see right now. So as you can see, like it's basically loading. You don't really need to understand these messages that are up there, but now since there has been a change in requirements.txt, you can see these gray lines which did not occur before. All the requirements.txt is basically being reinstalled, and this might take slightly longer. So whenever you change the requirements, or if you have additional dependencies, or the flow of your Docker file essentially changes, let's say if a command has not been cached, then Docker knows to run the commands again from scratch. So as you can see, just so that there's no doubts, so you're running the DB container first based on the environment file that's here, and once that is done, this service is being run. So you're specifying all these. You can basically search this up on the documentation, or you can refer to the GitHub link that I'm going to send to you. But it's kind of self-explanatory as to what each one does. But you just need to know essentially these are like config options that you have with you. Okay, so this is taking a bit of time to set up because there are multiple dependencies. It's quite a big project. So yeah. While that's happening, I will proceed with other concepts, which is basically pertaining to how you would push your backend service to GCP Cloud Build and Cloud Run. So I technically push both your containers to some compute service, but the disadvantage of that is that it would you would basically be running it 24/7, and you'd be paying even when nobody's calling the API. So when you need GCP Cloud Run, the biggest advantage of it is that you only have to pay or only have to use your credits when somebody is calling the API, or if there is an instance of Cloud Run which is actually answering requests. So in the scale that you're working with, one single instance of Cloud Run can actually work, can actually handle about 80 requests concurrently. So you don't need to really worry about scaling, but Cloud Run does help with that as well. So without further ado, I'll just introduce a few concepts. Okay, never mind. Actually, we can see that the containers have been created. So all these instructions have been run, and you can see that the service has been created, and you have, so this is called Docker Desktop. I've put the instructions to download this in the Orbital page for this mission control. You can check it out. So this is essentially the network that you see here. It's called FBI, and you have two different containers that are running. And if you look at your images, you can see that these two images are currently in use. Unused images, it's better to prune them using a command called docker prune, but it's not super important. You can just essentially just delete them as they are here. But these are essentially the images that are being built into containers. As you can see here, you also have volumes. Yeah, and so essentially, let's say if you have let's say we want to connect to this database. So one way we can do that is using a Postgres client called Table Plus. So if you're on Windows, would highly recommend this. So let's create a new connection. So just 1 second. Okay, so I'm going to create a Postgres connection. So this is a DB client. So I'm just going to call it local DB demo, and I'm just going to copy over the credentials that I had. So I think my local host is, okay, I'm just going to get user is, so my host is localhost because it's running locally. The port is 5432, and the password, okay, I'm just going to copy it over. And the database is called FBIDB. So let's test the connection. Oh, my bad, it's 5433. Interesting. Okay. Password authentication is failing. Okay, interesting. Let me just look at what's gone wrong. Interesting. Okay, not too sure what's gone wrong here. Okay, so probably messed up something there. Sorry about that. Let me take another example of a Docker container. So let me just put this on hold. So I have a backup here because I expect stuff like this would happen. So I have a different network that I'm running. So let me just pause this and run these containers. Oops, okay. So okay, so I have Postgres here, and so I'm just going to run these two separately, and I'm just going to delete this. Okay, so this is just a backup I have in mind. So for some reason, the authentication is failing here. Probably take me a bit of time to debug, so I'm not going to go into that. So this is another database that I have, and for simplicity, I just put everything as Postgres. So let's say if I'm trying to connect to this, so I have Postgres and demo 2 host is Postgres 5432, user is Postgres, password is also Postgres, I think, and the database is Postgres as well. Oops, should be localhost. Yeah, so you can see the connection's okay. So let's say if I connect to this, and as you can see, I just spun up the container, and because I had Docker volumes, you can see that the data that I've already stored prior to bringing down those containers is already here, as you can see. So essentially, that's why Docker volumes are super important. You don't want it that, like for some reason when your container stops running, this can be either when you're closing down Docker desktop or if you're shutting down your computer, you basically will need to stop your containers. You don't want to lose that memory because it's being persistent consistently in RAM. So that's essentially why volumes are pretty important. Sorry about the fact that it didn't work with the current the port where I was not able to connect to it, but I hope this gives some sort of an understanding as to how you would essentially spin up your database and connect to it. I was running into some authentication issues, which I will need to debug on my own time. So yeah, in the interest of time, I just chose to use a backup. Sure. So now that you've seen that, you can spin up a Postgres container and you can connect to it. Yeah, it's pretty, I guess, convenient to be able to connect your backend service to the database. So using Docker. So that's an example. So Docker Desktop is basically a GUI service that allows you to look at the instances or containers that you're running and see the status of each one. So for example, here you can see that these are like sort of API requests that have been made. So I have an endpoint called chat, and then the request for the same have been made. So let's say I should have this at the same time. So this is basically another demo I made for a different workshop, but let's say so if I say what is orbital here, ideally I should see the logs here coming. So it's quite helpful for like local development and deployment. So as you can see, the post request that has been made, you can see that it's okay, and the response is here as well. So yeah, it's quite, you would use this terminal, the logs here, Docker logs, for basically looking into what print statements or log statements that you have in order to be able to debug your application a lot better. And as you can see, the reason I mentioned UVcorn and Reloader is basically to ensure that any changes that are made to your backend application. So let's say if I do any sort of change, it will basically shut down the container and then restart. And you use volumes again because you don't want to lose the data when you're restarting. So yeah, without further ado, we'll proceed to Cloud SQL and GCP Cloud Build and Cloud Run to basically deploy your backend service. The reason we're going in reverse order, where we're deploying SQL first, then Cloud Build, then Cloud Run, and then finally Vercel, is because it's a dependency. Cloud SQL does not depend on anything. It's a standalone database. So it's quite simple to set up. And for Orbital, obviously the minimum config will do. So what do I mean by minimum config? Let me pull up Cloud SQL. So essentially how to get this page, let me just show you. Go to console.cloud.google.com. So yeah, I created a new account because free credits. You get like $300 worth of credits, by the way. So it led me to Cloud Run, but that's not the service we're looking for. We go to the search bar and we search for Cloud SQL, and we can see that it will lead us to a different service. So GCP essentially consists of multiple services. Cloud Build is a CI/CD service. So you basically pick a project. So if you don't have a project, so I already have one called FBI Prod, but if you don't have one, you would essentially click on New Project, and then you would create your own project with a new project name. Since I have one, I will not be creating a new one, but it's pretty straightforward from what you can see here. Then once you create a new project, under the project that you've selected, you can essentially create and instantiate multiple instances. An instance is basically a service that you're either paying for or with your own pocket or through your own credits. So I have pretty decent amount of credits remaining. Yeah, I was kind of using it a lot for whatever reason. So, but as you can see, it's you've created a new instance of Cloud SQL. So my instance ID is called FBIDB. So essentially how you would create an instance is you would go here. You can either choose MySQL, Postgres, or SQL Server. And in my case, since I use Postgres to develop locally, and my code would work with Postgres, so I would choose PostgreSQL. Yep, it's a bit laggy, not sure why. So in this case, you can always choose the minimum configuration. So I'm not going to be creating a new instance right here because I already have one, but I'm just going to walk you through the process. So you don't need Enterprise Level Plus. For Orbital, Enterprise will do. And this is obviously much better than what most other providers provide. Postgres, you can use honestly anything from 15 onwards, works well. You have to create your own instance ID, and you can create a password. So this is basically the password that you need for authenticating. So yeah, once that's done, you select a region. This honestly does not matter much, but if you have to choose, obviously choose something that's closer to Singapore because like lesser access time, right? So in my case, the other one I chose Sydney because I needed to use it in Australia, but yeah, ideally you would want to create your instance close to where most of your target users are in order for quicker data access. And the same principle applies to Cloud Build and Cloud Run as well. So yeah, you would ideally choose Asia, and you have Singapore here. So you ideally want to use this. Zonal availability, really you don't need multiple zones. You're good here. So yeah, you can choose one of these. These are just different locations of where the data centers are. You can configure. Yeah, do be pretty careful here because the default is 8 virtual CPUs. So you'd ideally want to set it to either 1 or 2 because otherwise your hourly costs is going to be a lot more. So let's say if I choose 8, as you can see from 18 cents it goes to like 86. So be pretty careful here. Don't yeah, don't can even use a shared core and now you can get it to 13. So yeah, always try to go for the minimum initially because when you're not having many users, it doesn't make sense to spend too much on. And again, here, GCP tends to trick you, so just make sure that you go for the smaller, the most, um, the cheapest option. So now that you see, I've gotten it down to like 5 cents. Of course, the performance might suffer, but again, at the number of users that Orbital typically has, it really doesn't matter. So yeah, just a word of caution. So public IP is important because you're essentially going to communicate through HTTP or a database call from your backend service. So yeah, these are just some of the parameters that you set. I'm not going to be creating the instance right now, but you just have to click this button, uh, and then you will have an instance like I can see here. So let's just click on the instance. It'll take quite a while to create an instance. So obviously don't do this. I did this temporarily, but the instance allows access from any IP address. I basically ran into a course issue, completely unrelated, but yeah, that's just don't do that. Okay, so if you want to connect to the instance, so you have the public IP address, you have the port number, and you also have the connection name. This is basically the host name that you'll be connecting to. So let's try connecting to this. I believe I already have saved the connection here. Whoops. Shit. Okay. Okay, looks like I accidentally closed the network. Sorry about that. I'm just gonna restart. Okay, so I was at Cloud SQL where, whoops. Okay, so chosen the right project that I'm working on. Go to Cloud SQL. And this is my instance. And I want to connect to it using Table Plus, which is my DB client, DBMS client. So I'm just going to create a new instance. And this is my connection. So okay, so I think I can just edit this to be honest. Okay, so this is I created a previous SQL instance, but I will just update it with the most up-to-date data. So as you can see, my bad. So this is basically the host name. This is the host IP address. So I would use it for Docker for the host name here. So you're connecting not to a local database, but a remote database. And this is important because you need, when you're in a production environment, you need people who are who are using different laptops and are in different networks to be able to access data from this as well. So, and also you want your cloud environment that's running your API service to be able to access the database as well. So I'm using this. I think the password should be the same. FBIDB is also the same. Let me try connecting. And as we can see, the connection is okay. So I am going to connect to this. And as we can see, um, okay, so let's see if I, oops, okay, okay, so I've not populated with data yet. Okay, so I've created 4 users. So as you can see, um, at least there's some data here. Yeah, so that's essentially how you would create a Cloud SQL instance, and you would connect to it using your local RDBMS client. So typically, if you're using Windows, I would recommend Table Plus. If you're using Mac, and if you're using Postgres, maybe pgadmin is a good choice. You might want to check that out. Yeah. So let me go back to where I was. So now that we've looked into Cloud SQL, and I hope you know what I mean by minimum config, let's look at Cloud Build and Cloud Run. So uh, I assume by now you would have, at this point, if you've already set up Cloud SQL, you would have set up billing with your card. So you basically have to provide your billing details, and you get $300 worth of free credits to use. So typically it should last you till the end of Orbital. If it doesn't, no worries, just create a new account and then repeat the steps over again. It's a bit of a pain, but I mean, you get stuff for free, so why not? Um, so this steps should have been done before Cloud SQL. So create a new project, and then within the project, you've already created your Cloud SQL instance. So now we'll be looking at two things called Cloud Build, GCP Cloud Build, and Cloud Run. So Cloud Build is basically a continuous integration delivery platform. And what this means is that there are two things. One is integration and the second is delivery. Integration is basically in the context of Cloud Build. It runs essentially on Docker. So it takes the latest Docker file and runs all the steps as to how to build the image and builds a running container. And the latest container is basically deployed to GCP Cloud Run. So anytime you make any API request to the GCP Cloud Run instance, you get it basically reflects the latest changes. It takes about a minute or so to deploy the newest changes in GCP Cloud Run, but you can also always see the history of deployments so that you can revert to a previous deployment if need be. So I will be showing you how to do this using GCP Cloud Build and Cloud Run. It's pretty fast and it's continuous, so you don't. You can basically set it up such that it gets triggered upon every pull request to the main branch, and you can set multiple triggers. So the best practice is to set the trigger to basically push to the main branch, which means that any pull request to main would actually trigger a redeployment of Cloud Build and eventually new push of a new container to Cloud Run, so that the latest environment is always the latest code is always pushed on your production environment. Typically, this is not how you would do it in, let's say, like larger companies where you're working on internships. You would have on GCP, you would have another instance of Cloud Build and Cloud Run, and this would be deployed from a different branch. Let's say dev or test branch. So every time you push a new feature, you would essentially merge your pull request onto the test branch, and this would trigger Cloud Build and Cloud Run, but it won't deploy to the production environment. It would deploy onto the testing environment, where you would essentially monitor the logs and see if a new feature is working perfectly, do some sort of testing and make sure it's working perfectly, and then eventually roll it out to production by merging test into the production branch, which is probably either main or whatever you want to call it. So that's typically how the workflow would work when it comes to, like, let's say when you have a dedicated testing environment. Typically in Orbital, we don't expect students to be able to do too much into that front. So it suffices to have a local testing environment and a production environment, and just a simple pipeline that basically triggers upon every push to the main branch. So yeah, that's basically what Cloud Build does. And Cloud Run is basically a serverless execution. So any like cloud service typically is serverless because you're not managing your own servers, and it also helps with auto scaling when the traffic increases. But again, this is each instance of Cloud Run each core can essentially manage up to 80 requests, if I'm not mistaken, concurrently. So unless you have more than 80 users using your app at any single point in time, it is very unlikely that you will need to auto scale. You can always enable the option, but it's very unlikely that it will go to that. But basically, if it does auto scale, it does mean that your credits are being used up more frequently than it normally would. So what GCP Cloud Run does is basically runs containers, um, which is basically Docker containers. So it's language and framework agnostic. And so it basically, even though I'm showing this all with Python, with Django, you can use it for any Python um, backend framework, or not even Python. Let's say if you're doing .NET, or let's say Node.js, Express, you can still use this, because all that matters is everything that you need has been packaged into a containerized application using the Docker file and Docker Compose. Very important is that now, since we moved away from the production to the moved away from the local to the production environment, you would only need to rely on your Docker file, and you don't really need your Docker Compose. Docker Compose is only for the local, where you're setting up a local instance of Postgres, where your backend service is communicating with your Postgres DB. But when it comes to like your production environment, because you've already set up Cloud SQL on GCP, which is the easiest way to probably set it up, all you need is your Docker file, which builds a standalone container, which is used to build a standalone container of your REST API service, and that can be deployed onto GCP. So yeah, it integrates with other Google Cloud services such as Cloud SQL, as I will show in a brief while. But typically you would configure that into something called your environment variables. So as I mentioned before, your env file is pretty important to keep it safe. Let me bring it here. So within backend, you will have, there's another env file which has all these important stuff, important API keys and everything. And this is necessary because it basically feeds into your backend application, and you would not be able to run it unless you had these secrets configured somewhere. So GCP Cloud Build provides a very useful way of managing your secrets, and we'll be showing this to you right now. So let me just make sure that I'm not, okay. So this is basically your build history. So this is Cloud Build, and now I will be bringing Cloud Run. So this is what it looks like. I will go into detail as to how you can configure these. So these are, what you see here are all latest builds that have been deployed onto Cloud Run. And every time I make any sort of new push, yeah, I made a lot of pull requests on April 11th. So you can see every time I push something new, there has always been a new deployment onto production. So green means that the deployment was successful. If it's red, it means that it's failed. Unfortunately, it's not showing the previous failures, but there have been cases where the deployment has failed in the past, probably due to some production issue of like not mentioning the dependencies correctly. So then what you need to do is essentially look into the logs here, and you can see what's going wrong. Typically, if you're using print statements, it may or may not work. I don't remember this correctly, but the best practice is to use a logger. So if you're using Python, you just import logging, and then yeah, just mentioning this as a side note. Okay, so then let's maybe look into how you can create a new instance of Cloud Run. So I'm just going to go to console.google.com, and obviously I'm not going to create a new instance right now, but I'm just going to walk you through the process. And right before I press create new one, I'm just going to check it out. So Cloud Run. So I have this. So let's say if I want to deploy a new connect. So ideally, if you want to set up a CI/CD pipeline, the best way to do it is actually just connect a repository. And so GitHub is my choice. So you would want to set up with cloud build. So this leads you to a new panel here. So you know that it's already been set as GitHub. So this has been already recognized by Cloud Build, but let's say if you want to add a new repository, let's say if I want to do it for a different repo, then manage connected repositories. This will lead me to my GitHub. And yeah, these are like the list of repositories that I have. So let me choose another one. Okay, so this is basically the one under my GitHub. So let's say I've put only select repositories. So if I want to use a different one, let me choose another. Okay, let's just choose this. So let's say if I save, now GCP Cloud Build can identify your new repository. Then you just need to accept this, and then build logs will be sent to GitHub. Okay, this is going to take a bit of time. So build configuration is as follows. So your deployment basically is dependent on a particular branch, which should be your source of truth. Ideally, in this case, it's main. But let's say if you have a dev and prod environment, then you would use dev and prod respectively. So this usually you use a regular expression to manage this, but basically you can see what all branches are there. So I just wanted to be main. So the build type, best to go for a Docker file, and the source location, since I'm using a mono repo, it has to be /backend/Docker file. So just for context, I will go onto the GitHub. This is the repository that I've connected. So as you can see, this is a mono repo where I have front end, which is in React, and then I have the backend here, and the Docker file is under the backend repository. So I would do that backend Docker file, and then once I do save, okay, it does not create a new. It has not created a new instance of Cloud Run yet, because I have not set up the other stuff. So I have set up the source repository, and then I need to set up Cloud Build triggers. So basically any push to main would essentially set up the triggers. Okay, I've done that. So you can set up your service name, so Orbital chatbot, and the URL is basically where you'd be connecting to where you'd be sending your REST API requests. So it's there, and then minimum number of instances. So you can set it to 1 to reduce cold starts, but the problem is that you would be paying a lot more. So that's there. Very important is containers, volumes, network, and security. So the most important thing here is your variables and secrets. So all your environment variables. So if I have an env file here, I would basically copy all the secrets here. Obviously, I would replace this with a production prod version of it, and I would copy these over. So essentially, if I wanted to add a variable, it would be, so just for example, let me say super tokens API key, because it really doesn't matter exposing this. But yeah, I would just copy this over, and then I would just put it. Yeah, so that's basically how I would add environment variables, and then I would save all of this. I would put done, and then yeah, it really doesn't matter what you put here. Just go with the default, and then you click on create, and then once you do that, you will have a cloud instance. So you don't need to set up Cloud Build separately, because once you do connect repo, GCP automatically sets up the Cloud Build for you. So once that's done, you basically have an instance. The reason I'm using an existing one is because it does take some time for these instances to spin up. So in the interest of time, I'm using an existing one. So the deployment type, as you can see, is repository. Region is, yeah, so the cloud build trigger will be created once you create the service. So I'm not creating it, so it's fine. So if I want to go in and see here, you see the logs, I can see different metrics. And if I want to basically send any API calls, I can use this. But however, there's I need to authenticate the endpoint, so it's definitely going to return a 404, but just to ensure that it works, as you can see, this at least shows that the URL exists. It just shows that the path is not there, but the URL does exist. So once we have the front end, and I'll show you how you essentially connect the front end to it and how you can make API requests. So just for an idea of how the CI/CD pipeline works, I will use the existing repository that I've used, which is this. Okay, so I'm gonna make a dummy commit on my backend. So let's say I go to views, and then for some reason I'm just going to remove one line here, and I'm going to save it, and then I will comment this git add backend git commit add remove white space git push. So let me just check on the right branch. Git branch is, yeah, I'm on main, so git push. Okay, so now that I've pushed to main, there'll be a trigger. So let me just refresh. As you can see, this means that this pipeline is pending, and it's going to be running these. I'll come to Vercel in a bit, but basically it's running the backend first. One is in progress and two pending checks. So it basically ensures that anytime, it'll take a while to run, but anytime you make a new commit, this pipeline has been triggered using GitHub Actions, and GCP actually manages everything for you. So yeah. So that's essentially how Cloud Run and Cloud Build works. I'll probably come to this towards the end after I cover Vercel. So as you can see, first we did SQL, and since the backend service connects to SQL, we set up the backend service such that it's able to query data. And just so that I can reiterate, so you can see that this is the build history. This is the latest build that's happening, and these are builds that failed for whatever reasons, right? So let's maybe show an existing Cloud Run instance just to show you how you would configure the variables and secrets. So here I chose the minimum, okay, 512 MIB. So let's go to variables and secrets, and you can see that there are different secrets that are here. And if you go to the env file, whatever secrets that are here and in this env file, because I needed to use a combination of both, whatever is needed by the application has been put in here. So make sure that every variable and secret that you're using, that you need, has been inserted here. Sure. So okay, so that's basically how it works. I'm not going to redeploy again because there's already a deployment in process. So you can see this is the average time it takes to deploy new containers onto production. But since I changed only the since I only changed one line, I didn't change much, the CI/CD pipeline should work, hopefully, but yeah, time will tell. Okay, so the last part of today's workshop is Vercel. So let me bring that here. So just a quick introduction into what Vercel is. It's probably the easiest way to deploy front-end applications. So if you're using React, Next, or any very popular front-end framework, it's extremely simple. Just sign into Vercel, create a new account. It's totally free. You create a new project. So if you go here, you can see that I have existing projects. So you can also create teams, but I think that's underpaid. You can add a new project here, and very roughly what you would do is you would connect to a repository, you would import this, and then basically follow the instructions and then build. So let's see if I tried importing this. Yeah, so again, similar to the backend, you have to specify the root directory. So you need to specify that it's front end, and you would probably give it a project name. Your project name would basically be the URL that you're using. So it'll be like fpi2.vercel.app, and then you can specify the environment variables here if you want to. Another alternative that I'll show you is also under the settings page, but I'm not going to deploy this because I already have a deployment ready. So let me go into that. Okay. Yes. So I have an existing project, which is this. So I'm going to click on this. So this is the latest production deployment that has been done, and those are the branches. So this is the latest. So as you see, because I need to refresh this. Yeah, so I just removed white space. This is the latest comment that I made, and there's been deployment on all three fronts. Ignore FBI docs, it's irrelevant, but basically this is the latest deployment that is done, and we can see it's here. Every deployment has a unique ID, and you can click on it just to see the latest version. So if I go here, just to make sure that I'm able to connect to the API, I will, maybe I'll create a new account. So I'm just going to create a path with Orbital. Okay, something that's went wrong. Okay, that. But basically, okay, do I have an existing? Okay, sorry, I do have an existing version of it that works. So as you can see, this has been taken from oh no, mine's logos. But basically, yeah, you can click on previous deployments. So fpi.vercel.app is going to be the latest deployment version. Again, I'm probably going to have to debug this in my own time. So, okay, never mind. I do have a user profile page. So as you can see, this response is only being called when, excuse me. Right, so my hypothesis as to why it didn't work previously when I tried to sign in is because I basically didn't allow for an instance to be running all the time. So this led to cold start issues. So again, you might run into these kind of issues where a REST API is not able to answer or respond to the request that you're making because of cold start. So since I already made a request, the Cloud Run instance was kept warm. So the reason I'm saying this is because it's very useful when it comes to debugging. And yeah, so ideally you would want to keep at least one Cloud Run instance running all the time. So yeah, that was the issue. So it's working now. I'm signed in, and yeah, so this is fpi.vercel.app. If I want to look into like previous deployments, I can do so by clicking on this. So it's going to be the same, it's going to work, but it's not going to be the latest, but it'll lead me to a different URL. So I can test different versions of the front end as well. So that's a good thing about Vercel. The only problem is that if you want to get rid of this name, you need to pay extra, but yeah, who cares? All right, so that's about Vercel. Maybe I'll go a bit more into how to set up a connection to the REST API. So you need to set up environment variables. So if I look locally, this is my front-end code, and I have an env file here, and these are the environment variables that I'm setting up. This is the mock data URI, but I'm not connecting to this database, so don't get confused. But these are the more important URLs. So as you can see, this is here it's localhost. So you should not be copying this verbatim into your production environment, because there your production URLs also change. So here it's pointing to localhost. You have to make sure that you're pointing to the correct application. So this, by right, since it's local, the backend URL should be actually be referring to localhost, but for testing purposes, I put it to production environment. But ideally, it should be local. So just don't get confused there. So, okay, dismiss. So let's say if I want to add a new environment variable, I added one right before the call, which is before the workshop, which is why it shows as such. So I go to settings, I go to environment variables, and then I can add a new one here. So I can add client key, and then I add a value, and then I just press save, it'll get saved. Let's go into some of this important things. So that's your domain. You can manage your domain name here. You can edit it as well if you want to, but won't be doing so. Okay, yeah, very important is build and deployment, because you need to, there are different commands that Vercel gives by default, and previously I was having a lot of these build errors. Sorry, not here, on Vercel. So a lot of my deployments were failing because of not installing with regards to peer dependencies. So as you can see here, npm install was basically breaking. So in order to debug this, or rather to combat this, I went into settings, build and deployment, and then instead of install, so your typical command would be npm install, yarn install, or some pnpm install, but in this case I override it with legacy peer dependencies, which makes sure that even if you have older versions of dependencies, there is not much of a conflict. There's not a conflict. As you can see, I've set up the root directory to make sure that you're building inside the root file, inside the front end directory. And as you can see, the front end is the one that contains all the important configuration files, package.json, etc. So that's the, I would say, rough intro to what Vercel does, and essentially how you deploy a front-end application. It's of course quite a brief introduction, but you basically have to just follow the website, and it's pretty intuitive, the user interface. I just wanted to cover the key concepts as to how you would set up a connection to the database. How you set up a connection to the backend server. And as you can see, I think I missed this. Basically, for the backend URL, so if I wanted to edit, so as you can see, this is the same as the Cloud Run instance that's here. So let me just copy this over, and it's the same, right? So this is how I would connect to the backend. So I've set up the URL as a secret or rather an environment variable in Vercel. All I have to do is save, and then these variables, environment variables, would be fed into the application, and then the application would know essentially how to call the backend. So locally, you would be sort of simulating the network call, the HTTP request between the front end and the backend. but in the production environment, they're physically different environments. So you would need to specify the URL this way. So that actually brings me to the end of the workshop. Happy to answer any questions if you have. And yeah, you guys have any questions. So you can either put them in the chat, or you can um, feel free to ask them. Feel free to unmute and ask any questions that you may have. Okay, so if there are no questions per se, I'm just gonna leave this open until 12. And after that, like I'll be looking at the chat if there are any questions, and feel free to just leave the call if you have no other questions. And yeah, I'll be uploading the recording pretty soon. So yeah, and if if at any point of time, like, you have any questions that you might want to ask, you can always email me. I think you should be able to find it on Canvas. But yeah, so yeah, just feel free to either stay on till 12 or leave. Okay, so there is one question. Is there a type of product for GCP to store files like documents? Sure. So you would be ideally looking into an equivalent of like blob storage. So typically, I've worked with Azure before, so there should be something similar for GCP. Let me just quickly search it up. Object storage. Yeah, so you would basically be looking at something called GCP Cloud Storage. So if you see the link I've sent, it's basically a managed service for storing unstructured data. So you can store media, any sort of like video files, image files. So ideally, how you would be working with it is you would have a REST API, and then let's say you want to serve like some sort of a video or a static file as a REST API response. So the URL to the cloud storage, so every object that is stored on GCP will have, or any cloud service for that matter, will have a unique resource link, a URL essentially. You would ideally store that URL into your SQL database. And then for a particular user, let's say you want to retrieve an image or an avatar that has been stored on cloud storage, you would retrieve that URL, and then basically you retrieve the image using the URL by making a REST API request, and then you would serve the static file as a byte stream back to the front end. That's roughly how it would work. But yeah, I didn't have the time to cover it, but given that you've seen how I've worked with GCP so far, it should hopefully be fine. Hopefully that answers your question. Yeah. Okay, so there's another question that's come forth, which is I've worked with Express before, but now I am working with Next.js. Is Next.js a backend API service? Okay, is Next.js a backend API service like Express? I get confused with building my own API calls using Next.js. So Next.js is actually a layer on top of React.js, and it can be used as both a front end and a full stack framework. So it uses something called server-side rendering, and you can have server-side requests So you would basically have, if I remember roughly, so I've not I've used Next.js mainly as a front end framework, but it can also be used as a full stack framework. So you would ideally may have some a folder called API, and under the API you would have like some routes, and you would manage everything into a single repository. And Vercel, if I'm not mistaken, will take care of the server side rendering for you. So if you're using Next.js as like a full stack framework, you can use it to make API calls. It gets a bit confusing, I understand, because you are the routes and all, you're managing everything within a single framework, but the framework is intelligent enough to know that the API logic that's being handled and the endpoints should be rendered on the server side, and all the calls are being made from the client. Not sure if that makes sense to you. Like, yeah. So can I build my own MVC type of structure using the API or use? Oh, actually, I'm not sure what the question your question is. Like, are you asking if you can build like some sort of MVC type of API service? Yeah.
No, no. So, example, because when we use Express.js, we keep real like we create a folder called like models, and then per se, I want to build a model of user, and then
Right.
that user has a view and a controller, right?
Right.
I'm asking a question of how can I do the same thing but using Next.js?
Okay.
Because yeah, because I
Okay.
get confused about the Next.js because they use a folder structure, but
Okay.
in Express you can just write your API routes as like a
Right.
single
Okay.
functions.
Right. That makes sense. Yeah. So you would, if I'm not mistaken, it's very similar in Next.js. I have not used it for building APIs, uh, though I'm like remotely familiar with how it works. But ideally, you would have your own. So your question is basically how can you use it for some sort of like MVC, so where you have models and then you're able to connect to a database and then
Yeah.
oh, okay, yeah, so it's essentially the same. So whatever you would put as a standalone function in Express.js, you would have it in Next.js as an API endpoint under the API folder.
Okay.
Yeah,
Yeah.
so
Uh,
when it comes to like interacting with databases, you would need some sort of an ORM. I know in Express you have type ORM that helps you connect to the database such that you don't need
Yeah,
to.
I think for MongoDB they have this ORM called Mongoose that I used before. But I
Okay.
think now that uh, I'm using Postgres. I think
Okay.
I did found an ORM, but I'm also if you're using an ORM, is it good to use Supabase or just build my own database like from scratch?
Okay. I've worked briefly with Superbase. Superbase is mainly like backend as a service, if I'm not mistaken, right? Like it's not. Uh,
Yeah,
yeah.
because when I read the documentation, it looks like they actually have their own API to like register users and whatnot.
Right, right. Yeah. So if you're using Superbase, maybe ORM does not make much of sense because I assume they would have their own API calls to, add records and delete them per se. Superbase should be NoSQL if I'm not mistaken.
So
Yeah.
yeah, I think I'll do more reading up on it. It's just as I read, I get more questions. Cause back when I did it, like I did everything from like Express. I built my own database.
Mm-hmm.
But now that we have like so as you say like Superbase, which are like they reduce the effort, right? So
Mm-hmm.
it's like you need to read. It's like reading a lot of documentation, understanding how
Documentation, yeah,
to.
makes sense. But I would think that you wouldn't need to use an ORM if you're using Superbase, because they probably have their own API calls to, um, essentially do basically front operations on the data. So yeah, I doubt you will need an ORM, but if you're using Postgres, sorry, you said you're using Postgres or Superbase. I missed.
I'm using Supabase, but I think Supabase has Postgres SQL. Like they use that as their database.
Interesting. Okay, so if you're using Postgres, okay, so you're using Superbase to host a Postgres instance. Would that be correct?
Yeah.
Okay, so if that's the case, then maybe you would need an ORM because eventually the only thing is that Superbase is managing the database for you, and you are essentially you would need to connect to the database in some way. So unless they have some sort of an API call, best to use an ORM. And ORM typically is going to be better because ORM is typically better because, let's say, if you're changing your SQL provider for some reason, you have a common interface to, like, interact with the database. Does that make sense?
Yeah, it makes like initiating my models easier. If I already define my models in my backend, then
Mm-hmm.
I can just call from Supabase and then initiate all the models, like, and then just interact with them. Yeah. I'm still reading up on it. Yeah.
Right, sure.
Yeah.
Yeah. So I think there might be consultation sessions on databases if you're confused at any point in time. So you can probably sign up for those. There should be one next week. So yeah, somebody who's more experienced with databases can help you with that. So I've only roughly worked with Superbase and Postgres. So yeah, it's really like, yeah, you might have to do a bit more reading. Yeah.
Thanks for answering the
Yeah, no
questions.
worries. Yeah.
Yeah. Yeah.